The term "if available" in the context of grounding electrodes means that the electrode is not always required to be installed, but it is an available option for meeting the grounding requirements of a building or structure. If the architect or building owner specifies that they do not want the building steel bonded or a grounding electrode installed in the footing, the electrician is not required to install these grounding electrodes. However, the electrician must still ensure that an appropriate grounding system is installed in accordance with the applicable electrical codes. Rod and pipe electrodes are readily available from electrical supply houses. Plate electrodes are not as common as rod and pipe electrodes, but they are typically available upon special order from electrical supply houses. Whether or not supply houses should start stocking plate electrodes depends on the local demand and the frequency with which they are used in the area. In areas where plate electrodes are commonly used, it may be beneficial for supply houses to stock them. In special circumstances, a single rod or pipe electrode may be the only grounding electrode connected to a surface. This is typically permissible in areas where the soil resistivity is lower and there are no other suitable grounding electrodes available. However, it is important to note that this is not a preferred practice and should only be used as a last resort. The availability of grounding electrodes, including plate electrodes, varies depending on the supply house and the local demand. While not always required by the building owner, plate electrodes are an available option for meeting the grounding requirements of a building or structure. In special circumstances, a single rod or pipe electrode may be the only grounding electrode connected to a surface. When addressing grounding electrodes, consider the requirements outlined in the National Electrical Code, or NEC. Grounding ensures a safe path for fault current, protecting people and equipment from electrical shock and damage. Firstly, let's delve into the types of grounding electrodes recognized by the NEC. These include metal underground water pipes, the metal frame of the building or structure, concrete encased electrodes, ground rings, rod and pipe electrodes, and plate electrodes. Each type has specific installation requirements and suitability for different situations. Secondly, the NEC specifies that a grounding electrode system should be used whenever possible. This system consists of multiple electrodes bonded together to provide a low impedance path to ground. The most common combination is a metal underground water pipe supplemented by an additional electrode, such as a ground rod or concrete encased electrode. Thirdly, the phrase "if available" becomes important when considering the feasibility of using certain electrodes. For example, a metal underground water pipe may not be available if the building has a non-metallic water service. Similarly, the building steel might not be accessible or suitable for use as a grounding electrode. Fourthly, when the architect or building owner expresses a preference against using certain grounding electrodes, such as the building steel or a footing electrode, it's crucial to understand the implications. While the preferences should be considered, the electrician ultimately has the responsibility to ensure compliance with NEC and to provide a safe and effective grounding system. Fifthly, in such cases, alternative grounding electrodes must be used. This might involve installing ground rods, ground plates, or a ground ring. The selection of the appropriate electrode depends on factors such as soil resistivity, available space, and local regulations. Sixthly, the availability of grounding electrodes from supply houses can influence the choice of grounding methods. Rod and pipe electrodes are typically readily available, making them a convenient option. Plate electrodes, on the other hand, might require special ordering, which can add to the project's timeline and cost. Seventhly, the decision to stock plate electrodes depends on the local demand and the frequency of their use. In areas with high soil resistivity or where space is limited, plate electrodes might be a more common choice. In such cases, it would be beneficial for supply houses to stock them to meet the needs of the local electrical contractors. Eighthly, the NEC permits the use of a single rod or pipe electrode as the sole grounding electrode under specific conditions. This is allowed when the resistance to ground of the single electrode does not exceed 25 ohms. If the resistance exceeds 25 ohms, a second grounding electrode is required. Ninthly, it's important to note that using a single rod or pipe electrode as the sole grounding electrode is generally not the preferred method. A grounding electrode system consisting of multiple electrodes provides a more reliable and effective path to ground. Tenthly, when installing grounding electrodes, proper bonding is essential. Bonding ensures that all metallic parts of the electrical system are connected to the grounding electrode system, creating a low impedance path for fault current. This includes bonding the service equipment, metal enclosures, and any other metallic components that could become energized. 11thly, the size of the grounding electrode conductor, which connects the grounding electrode to the service equipment, is determined by the size of the service entrance conductors. Table 250.66 in the NEC provides guidance on selecting the appropriate size of the grounding electrode conductor. 12thly, the installation of grounding electrodes must comply with specific requirements outlined in Article 250 of the NEC. This includes requirements for the depth and spacing of electrodes, as well as the methods for connecting the grounding electrode conductor. 13thly, soil resistivity plays a significant role in the effectiveness of grounding electrodes. High soil resistivity increases the resistance to ground, making it more difficult to dissipate fault current. In areas with high soil resistivity, it may be necessary to use multiple grounding electrodes or to consider soil treatment methods to reduce the resistance. 14thly, concrete encased electrodes, also known as UV-grounds, are an effective grounding method, especially in new construction. These electrodes consist of a length of bare copper conductor encased in concrete that is in direct contact with the earth. 15thly, ground rings are another type of grounding electrode that can be used in certain situations. These consist of a bare copper conductor buried in a continuous loop around the perimeter of the building. 16thly, when selecting grounding electrodes, it's important to consider the potential for corrosion. Some types of electrodes, such as steel ground rods, are susceptible to corrosion in certain soil conditions. Copper electrodes are generally more resistant to corrosion. 17thly, the NEC requires that grounding electrodes be protected from physical damage. This can be achieved by installing the electrodes in a protected location or by using a protective sleeve or enclosure. 18thly, it's crucial to maintain accurate records of the grounding system, including the type and location of grounding electrodes, as well as the results of any ground resistance tests. This information can be valuable for future maintenance and troubleshooting. 19thly, regular inspections of the grounding system are essential to ensure its continued effectiveness. This includes checking for corrosion, damage, and loose connections. 20thly, grounding is a critical aspect of electrical safety, and it's essential to have a thorough understanding of the NEC requirements and best practices. By following these guidelines, electricians can ensure that electrical systems are properly grounded, protecting people and equipment from electrical hazards. The NEC provides detailed requirements for grounding electrode systems. The grounding electrode conductor connects the system to the service equipment. Soil resistivity affects the effectiveness of grounding electrodes. Regular inspections and maintenance are crucial for continued safety. Metal underground water pipes, building steel, and concrete encased electrodes are common options. If available means the electrode is an option, not always a requirement. Architect or owner preferences don't override NEC safety mandates. Rod and pipe electrodes are readily available. Plates may require special orders. Stocking plate electrodes depends on local demand and usage frequency. A single rod or pipe electrode is permissible under specific conditions, but not preferred. Bonding ensures all metallic parts connect to the grounding electrode system. Table 250.66 guides the selection of grounding electrode conductor size. Article 250 outlines installation requirements for grounding electrodes. High soil resistivity requires multiple electrodes or soil treatment. UV-grounds are effective in new construction. Ground rings are used in specific situations. Consider corrosion potential when selecting electrodes. Protect grounding electrodes from physical damage. Maintain accurate records of the grounding system. Grounding is crucial for electrical safety and NEC compliance. Always prioritize safety and adhere to the NEC when designing and installing grounding systems. Consider factors like soil conditions, building structure, and local regulations. Consulting with a qualified electrical engineer can ensure optimal grounding system design. Proper grounding protects against electrical shock, fire, and equipment damage. Stay updated on the latest NEC revisions and industry best practices. Prioritize a comprehensive grounding electrode system for enhanced safety. The electrician must install an appropriate grounding system following electrical codes, even if certain electrodes are not desired. Soil resistivity, space availability, and local regulations also play a role in electrode selection. Proper bonding ensures a low impedance path for fault current. Regular inspections and maintenance ensure the system's continued effectiveness. Grounding is a critical aspect of electrical safety. Ensure the electrical systems are properly grounded, protecting people and equipment. The grounding electrode conductor size is determined by the service entrance conductor's size. Accurate records of the grounding system are valuable for maintenance.